Alright, welcome back everybody to another video, and in today's video we will be talking about factoring a simple trinomial. So let's think of an example here. If I have a quadratic function in standard form such as x squared minus 15x plus 50, then if I wanted to factor this, then I'm looking at this equation here and I'm looking at the a value, and you notice that the a value is 1, a equal to 1, because it's 1x squared. We just don't write it like that, we just write x squared. So when a is equal to 1, we know that this is called a simple trinomial. So what you're going to do is set up your PSI. So the product is always the product of the a value times the c value. So you can see it's 1 times 50. So the product is 50, and the sum is always the b value, which will be negative 15. So I need to find two numbers that multiply to 50 but add to negative 15. So if I'm thinking about this, I'm thinking about two numbers that multiply to 50. So you could have 2 and 25, 5 and 10, and then you realize that 5 and 10 should work because negative 5 and negative 10, they multiply to 50, but they also add to negative 15. So next, you're going to set up your double bracket, and you're going to put your x's, and then you're going to fill in your integers, so negative 5 and negative 10. So if you wanted to solve for the x-intercepts of this equation, because now this is in factored form, so you would set this equation equal to 0 because the x-intercepts occur when y is 0. For example, here and here. So they occur when y is 0. So you have to set the equation equal to 0, and then for this equation to be true, either this factor here, the x minus 5, has to be 0, or this factor here has to be 0 in order to make this equation true. So what you can do is set each individual factor equal to 0 and then solve. So x minus 5 equal to 0, move over 5 by adding 5 to both sides, is x equals to positive 5. Now x minus 10, add 10 to both sides to get rid of the negative 10, x equals positive 10. So these are your two x-intercepts of this function. So it could look like something like, maybe like this. Goes to 5, and it goes to 10. Now you could find the vertex. I'll explain to you how to find the vertex right now, actually. So if you want to find the vertex from the x-intercepts, you just have to take the average. So plus 10 plus 5 divided by 2. This is the average, say average of the x-intercepts, right? Equals, so 15 divided by 2 is 7.5. So this is the x-coordinate of the vertex. So the x-coordinate is 7.5. And to find the y-coordinate, you're going to plug this number back into the equation. So you could either plug it back into the factored form or the standard form. Does not matter. So let's just plug it back into the factored form. So put a bracket, 7.5 minus 5. Close the bracket, open up another bracket, and then the minus 10. So what does this equal? This is what the y-coordinate will equal. So you're going to do 7.5 minus 5 is 2.5. And then 7.5 minus 10 is negative 2.5. Negative 2.5. So 2.5 times negative 2.5 is negative 6.25. So that would be the y-coordinate of the vertex. There you go. So the y-coordinate is negative 6.25. And the reason why you can solve for the x-coordinate of the vertex this way is because you know that these x-intercepts will be divided perfectly in half by the axis of symmetry. So the axis of symmetry is the imaginary line that perfectly divides this quadratic function into two symmetrical halves, okay? Axis of symmetry. So the axis of symmetry is actually, well, it's the x-coordinate of the vertex. So this is why you can take the average of the x-intercepts, find the axis of symmetry point, which is also the x-coordinate of the vertex. So this would be one way of factoring a simple trinomial, then finding the solutions, which would be the x-intercepts, and then you could even go further and find the vertex of the quadratic so that you could graph this.